Good afternoon. Today's sessions we are going to see about the greedy techniques in design of algorithm. So greedy techniques to build a complete solution by making a sequence of best solutions. We are going to take an best solution, that is the optimized solution for any problems. We are going to take an optimized solution for any problems. So selection depend upon the actual problems. So from this, what is the best step from this point? So each one of the point we are going to select which is the best solution for this problem. So even if you are going to if you are taking a first step and we are getting the optimal solution. Next, from that optimal solution we are going to take a next best steps. So this is the greedy techniques. For the greedy techniques we have elaborates of applications. We are listed some of the applications: sorting, merging, Huffman encoding, minimum spanning tree, knapsack problems. For today's session we are going to see about the minimum spanning tree with the elaborations. So minimum spanning tree, a spanning tree of an undirected connected graph. It is connected, and if we are going to form a non-cyclic subgraph of a tree that contains all the vectors of the graph. So for the spanning tree we will be having the connected and undirected. We will be having the connected and undirected graph which will be having the cycle. From this graph we are going to form a connected. We are going to visit all the nodes at least one time. So that is the spanning tree which will not form a cyclic. Without forming a cyclic we are going to form a graph. So minimum spanning tree, for the minimum spanning tree we will be having the edges are being given. We will be giving the edges with the this an unconnected, just an connected graph with will not having the directions, undirected graph. So from the minimum spanning tree we are going to find the what are the minimum cost of the steps are there. So minimum weighted spanning tree of the tree is a subset of trees of a connected edge weighted undirected graph that connects all the vectors together without any cyclics and with the minimum possible of total edges. So without forming any cyclic, for this graph we will be having the cycles are been formed. For this graph the cycles are not been formed, and we have the minimum total cost. So we have first minimum cost is here, the one is the minimum value, and second minimum value is 2, the third minimum value is 3, and the fourth minimum value is the 4. So we are not selecting the 5, 9, 14 and 7. So the cost will be higher. So we are taking only the minimum values from the connected graph. So our example we are going to see about the first we are going to see about the Prim's algorithm. So from the Prim's algorithm we will be having and they will be giving on graph. The graph will be connected and they will be having the weights are given. So the graph will not have the directions. So it is an undirected graph with weight and the connected graphs. So that graph will be a forming graph with the given graph will be a cycle. From the given cyclic graph we are going to find a non-cyclic graph from this algorithm. So for the first we are going to giving the input as we will be having the edges and the vertices. So for the graph we will be having the vectors and the edges. So from the output we are going to have only the edges. What are the minimum cost of the edge? So we are going to travel from one edge to another edge, another node. So we are going to travel from the source to the destination with the minimum cost, the edges of minimum cost of the edges. So in V of t is the collection of vertices. So collection of vertices is being initialized by V of naught, V naught. So for the first node we are not going to select we will be having only the vertices alone. That is the node alone. We will be having the node alone. With the node we are going to take all the vertex. We are going to visit all the edges. So first the edges is also kept as empty. For each vertex from the starting number 1 vectors to last number of vectors we are going to do this operations. That is for each vertex we are going to, which is the minimum cost, to find the minimum weightage. So for every edge for every vertex for all the nodes we will be having the minimum edge. So some of the edge will be higher and some of the edge will be lower. Further, we are going to find the which is the minimum edge. So minimum weighted edge, which is that. So that will be added first, and after that the second, for the second iteration, for the second when the loop is executed next time. So if that that vertex is, that edge is less cost, means that vertex will be added. So if we find, first we will be finding the, we will be starting from one vertex. We will be starting from one vertex, and we will be, if the edge has been low cost, means we will be adding that vertex and the edge. So we will be adding that particular vertex first and the edge. So after the first edge, first vertex has been found, so next loop will be executing, and for the second iterations we will be finding that whether we are going to, whether it has the minimum weight. And when we are connecting the graph, it should not be form a cycle. We should be consider that we have to find the minimum weighted edge with, when the graph should not follow a cyclic form. So we should not have a cyclic. So after that we are going to return the t, e of a for all the edges. So now our example. So we have one graph. So we are taking the source node as A. We are going to travel to all the nodes. We are going to visit all the nodes at least one time. We are going to visit all this node at least one time. So when we are visiting these all nodes, we have to find the minimum weight edge. So for example, here the A to B having the 3. So if we are going for an F, which is the minimum edge we consider, here A to F is 5. So B to F is 4, C to F is 4, D to F is 5, and E to F is 2. So here the minimum cost will be 2. Minimum cost. So we will be selecting the F to E as the smallest cost. So we will be likewise we are going from the source to, we are going to find all the, we are going to visit all the nodes. So first step, we are going to start from the vertex A. We are going to start from the vertex A. So from the vertex A, we can reach to A, F and E. We can reach to A, F and E. So for the vector, we are selecting the vertex node as A. From A to, we can reach to B, we can reach to E, and we can reach to F. So A to B, we have the cost as E. So A to B, we have the cost as 3, and from A to F we have a cost as 5. So we are noting as the, for F vertex we are noting as the cost as 5. From A to E we have the cost as 6. So for the E vertex we are given as the cost as 6. For the C vertex, for the C node and the D node, we do not know, there is no direct connection to A and C and A and D. So for this two vectors alone we are giving as a dash and we are giving as a infinity, because we do not know how long it takes to connect to C and how long it takes need to connect to D. So for the two options alone we are going to give as the dash and higher infinity. So from this graph we are going to find which is the smallest cost. So for this A to B is 6 and A to E is 6, A to F is 5. So from this the minimum cost is A to B is 3. So we have highlighted the graph, highlighted in the graph as dark. So this graph will be comes under our visiting nodes. So once we have selected the two vertex A to B, once we have selected the edge, so that will be comes under the tree vertexes. So we have connected the tree vertexes A to B of the distance 3. So next step we are going to find the remaining vertex. We are going to travel all the remaining vertexes in the graph. So next the remaining vertex we have to travel from the vertex B. We are going to travel from the vertex B. So from the B we can reach C. So we are going to update the vertex C. So previous slide for the C we not have the distance and we not have the direct path. So for this upcoming, so next for the upcoming positions we have reached the B. From B we are going to find what are all the paths are available, what are the vectors are available. So from B we can able to reach to C and F and A. So A is already visited, so now we are going to not taking the A position. So we can select B, we can going for the C and F. So from for C it is the minimum cost of 1, and for the F we have the cost of 4. So in the previously in previous diagrams we have given the F to A, we have the distance as 5, but now we have from the B to F we have the values as 4. So 4 is less than 5, so we are updating the F vertices as we are going to visit the F vertex by V vertex of the distance 4. So here from this we are going to select which is the minimum path. So from C to B is the minimum cost of 1, all others are 6 and 4. So we are going to select the B to C vertex with 1 edge cost. So after connecting B and C, the B and C are comes under the tree vertexes. The remaining vertexes are we are going to find the vectors for D, F and the E. So for the D vertex, still now there is, before the slide we did not have the direction. After visiting the C path we have the direction that we can go to the D by the cost of 6. So we are updating the vertex D by C to 6, C to D as 6. So next path is E to A, that is self as 6 values, and next we have the F to B as 4. So F we can going to reach the, so last slides we find that for the F to B we have 4. So F to B it's 4. So from this we are going to find which is the smallest path. So smallest path is from, it is D to C is 6 and A to E is 6, but for the B to F is 6. So 4 is the smallest path. So we are selecting the 4 as the next shortest path, and we are going to travels to the B to F vertex. We are visiting the F vertex now. So after visiting the F vertex will be comes in the tree vertices. So that F vertex is, so the F vertex comes under the tree vertices. So now the remaining vertex what we have not visited is D and E. So from the what are the vectors we can visit from D means we can visit from C, F and E. For the C it is 6 cost, for the F it is 5 cost, from the E it is 5 cost. So the minimum cost is 5, that is coming from F to D is minimum cost of 5. Next the minimum cost for visiting E is 6, 2 and 8 from D. So we are going to 6 and 2 is the minimum cost, so we are selecting the 2. So from this distance, so D from F is 5 and E from F is 2. So the minimum cost is 2. So we are selecting the vertex as E vertex from F. So of the minimum cost of 2. So E to F will be coming under the path. So next vector is F to D of the cost of 5. So that path will be visited. So next is the Kruskal algorithm. Next example is the Kruskal algorithm. We are going to find see about the Kruskal algorithm. The Kruskal algorithm is at the minimum spanning tree of weighted connected graph of G. We have the, here also we will be having the vectors and the edges, and we are going to form a acyclic subgraph. We are going to form a acyclic subgraph of the vertex V minus 1 edges for all which is sum of the edges weight is the smallest. So we are going to find the smallest edge. Here also we are going to find the smallest edge for the graph, and it's not forming a cycle. We have to find, we have to check whether we are forming a cycle or not. So here also we have our algorithm. The in Kruskal's we are going to construct the minimum spanning tree for the Kruskal's algorithm, and the given input is the edges and the vertices of the graph. The output we are going to select the minimum spanning tree for the all the edges, set of edges composing of minimum spanning tree. So for the graph we are going to select the minimum distance, that is the minimum edges for the one vertex to the next vertex. So if you are, when we are encoding, so we are going to have the all the vertex. First we are going to initialize the vertex as infinite. So we are going to, whenever we are encoding vectors, we are going to add one count here. So from the first vertex, when we from the first node to all the vertexes, from the first vertex to all the vectors, the looping is going to be executed. So if the edge is form a acyclic means we can go for the another loop. We can find another vertex from this graph. So whenever we are encoding problems, the encoder will be added how much distance we are going to, how much nodes we are visited, and finally we will be obtaining the edge total. So same graph, we will be having the same graph here. So here we will be having the sorted list. So in the before diagrams we will be finding over one by one edges will be finded, one by one vertex will be finded. For here the sorted list for the edges. So first we are going to take all the combinations of the vertexes. We are going to take all the combinations of the vertexes. For all the combinations, what is the value, and we are going to write is it in ascending order. We are going to select the all pair of edge. We are going to select the pair of the edge with the weight. So and we are going to represent that in the ascending order. So first we have the number 1 is the minimum cost. So the minimum cost is from B to C and it is written as first. Next minimum cost from the graph is 2, from F to E. So from the E to F it is written as 2. Next minimum cost is the 3. It is from A to B. So A to B it is formed as a minimum cost of 3. Next the minimum cost is B to F and C to F. The both are we have the same values of 4. So we are writing the first, which node is A by the alphabet, we are writing as the B, and from the next C to F. So next we have the weight of 5 in both values in two vertices. The first vertex from the A to F and second vertex from F to D. So A to F we have 5 and D to F we have 5. So next the next cost is the higher order cost is A to E and C to D of cost of 6. Next the higher order cost is D to E of cost 8. So from this we are going to find the subgraph with a non-cyclic graph with minimum cost. So for each iteration we have to confirm that we are not forming a cycle. So first we are selecting the graph, which is in this graph the minimum cost is B to C. So we have highlighted the graph from B to C. So next minimum cost is from E to F. So next minimum cost is from E to F. We have to check whether this will be forming a cycle or not. So B and C and E and F will not form a cycle. So next we are going for the next iterations. So once the B and C vectors are visited, so we will be coming under the tree edges. So once we have finded the B and C, so it comes under the tree edges. So when we have from this minimum path, E and F is the minimum cost. So the minimum cost of the E and F will be comes next in this next slide. In the next slide, E and F will be comes under the tree edges, and we have highlighted the E and F with the bold. So E and F is the visited path. So next iteration we are going to find the next smallest weighted index. So next smallest weighted index is from A to B. It is from A to B, and From the highlighted materials, we found that A to B will not form a cycle. So we are connecting the A to B and we are marking A to B as a visited graph. We are marking A to B as a visited graph of the value 3. So next we are going to travel to the next node. So from the for the next node, we can have the values as 4. So first we are having the value. First we are going for the node from B to F. For the B to F, we have the minimum value. Next minimum value is the 4. So next minimum value we have obtained as the 4. So B to F, we have the next visited edge. So B to F is the next visited edge. So after that, so when you are connecting, next minimum cost is C to F. Next minimum cost is C to F. When we connect the graph C to F, it will be forming a cycle. That is, we have already connection between B to C and B to F. When we connected F and C, we will be forming the graph. So we should not take this edge. So we are moving to the next edge, A to F. So when we are connecting A to F, that also form a cycle. By A to B we are connected already, B to F is connected already. If we connect A to F, now it will be forming a cycle. So we skip this form also. Next we are coming to the D to F. D to F is the minimum cost. So if we connected D to F, so all the node in this are connected. So we are connected A, B, C, D, E and F. So when we are selecting the next iteration D to F, all the vectors are being connected. So next we are getting the D to F is a marking as a visited tree. So next is the Dijistra's. We are going to see about the Dijistra's algorithm. So Dijistra's algorithm is similar to the Prim's algorithm. So you are going here also we are going to find the shortest path between the two vertices. So it is an algorithm for finding the shortest path between two nodes in a graph. The Dijistra's algorithm is similar to Prim's algorithm for minimum spanning tree. Here also we are going to find the minimum path for the graph. So here are for our examples we are taking this graph. So here what is the difference between the Prim's algorithm and the Dijistra's algorithm? For the Prim's algorithm we are not going to add all the distances. We are not going to update the distance. But for the Dijistra's algorithm, for each path we will be finding all the distance and add the sum. So here we are starting node is from A. So from A to we are going to visit all the nodes. From A to we are going to visit all the nodes. So that is our target. So when we are visiting all the nodes, it should be confirmed that no vertex, we should not form a cycle. So the graph should not form a cycle. So we are going to start from the A vertex. So from the A vertex we can reach to B vertex, and from the A vertex we can reach to the D. So we are updating the remaining vertex. Once we have selected the A vertex, so from the A vertex we are going to update the B vertex and the D vertex. So from the A to B the cost is 3, from A to D the cost is 7. So we have updated this, but we not have the direct path between A to C and A to E. So we have given us the hyphen infinity. So because we do not know the path and how much long it going to be travels up for the A vector will not know how long it is going to be travel. So we have given us infinity. So from this we are selecting the 3 and 7. The minimum cost is 3. So we are selecting the next visited node is the B vertex. So we are selecting the B vertex next. So we have selected the B vertex. From the B vertex we can go to C and D. So both vertex we can visit the both vertex. So we are updating the cost. So for the before we don't have from C we not have any path, but now after visiting the B vertex, we can reach the C node. So when we are reaching the C node, the total sum we have to add the total path. So for finding the total path we have to add from the source node. So, source node from A to B is 3 and B to C is 4. So, we write it as 3 plus 4. So, total cost A to B is 3 and B to C is 4. So, from we are going, when we are reaching from, we are traveling from A to C, the total cost will be 7, we are given here. So, next is the D node. So, when we are going to travel from A to D, when we are going to travel from A to D, so A to B is 3 and A to B to D is 2. So, when we are adding this, we will be getting the 5. So, 3 plus 2 is 5. For the edge, for the node E, we not have the, still now we don't have any direct path. So, we are given as the hyphen infinity. From this, the minimum cost is 5, because we have the B to C is cost is 7. For the B to D, the minimum cost is 5. So, we are selecting the minimum cost of 5 from B to D, that is from A to B and B to D as the minimum cost. So, we have selected these nodes A, B and D. So, when we have selected the next node B and D, we are going for the next step, that is the B and D node are visited. So, from the D, what are the steps we can go? We are going to see. So, next path is from B vertex So, we have to write that B comma D, here we will be coming as the B comma T of size 7, we will be having the B comma T of size 7. So, the next minimum cost for the path is, when we have the remaining path is from A to, we are going to next from the D, we are going to the next path, we can from the D vectors we can go to the C vertex, and from the D vertex we can reach the E vertex. From the D node we can visit to the C node and the E node. So, when we are visiting the C node, by D node, we will be having the distance, already we have 3 to when we go by this direction, 3 to A to B is 3 and B to D is 2, when you are going by the D direction plus 5. So, already here 5, when we go by the path of D, we will be having the sum, total sum as 5. So, 3 plus 2 plus 5 will be having 10. So, instead of that we can go by A to B and B to C of the minimum cost of 7. So, next node is the E node. When you are traveling from E D node, it is 4, A to B is 3, B to D is 2 and D to E will be 4. So, we are giving as the A to B 3 and B to D as 2. When we are summing that, we will be getting as 5. Next, we are going to add this node. Now, add this vertex of the edge. We have the cost of 4. So, when you are adding this 3 plus 2 5, 5 plus 4 is coming as the 9. So, next edge, because from this we can find that from A to B is the minimum cost and B to C, the 4 is the minimum cost. When we go by the C, here we have 6, already we have traveled from A to B, A to C is 7, 7 plus 6 we will be having as the 13. So, for this we can go by this path, A to B and B to D and D to E by the cost of 9. So, from this we have visited all the nodes. So, here each one we have to add the previous values. So, A to B we have cost of 3, A to B we have the cost of 3. Next step, so from the A to B we have the minimum cost of 3. So, A to B we have the minimum cost of 3. Next we are going to the path, next path is A to B and B to D of length 5. So, A to B cost is 3 and B to D the cost is 2. So, we have to, when we are going to one vertex to another vertex and another vertex, we have to sum their edges, So, the sum 3 plus 2 is 5. So, next from the direction from A to C. So when we are going from A to C, the path is A to B and C of the length 7. So A to C of the length is A to B and B to C of the length is 7. So next we are going for the path A to E. When we are going to the path A to E, we will be having A to B and from B to D and D to E of the length 9. So A to B and B to D and D to E of the cos. So 3 plus 2 plus 4 we will be having as the 9. Total cos is 9. So likewise we can find the examples, we can apply our examples for greedy technicals. When we can from the greedy techniques we can find the best optimal solution for each iterations. Thank you.